Vibration and noise engineering for mechanical engineers. So, this time, we will explain how to reduce the vibration of mechanical structures using a spring mass model with 1 degree of freedom. As shown in the figure, the machine is equipped with a power source such as a motor. Power source often equals vibration source. When the motor is bolted directly to a structure such as a frame or other parts, the vibration from the motor propagates throughout. In addition, the large vibration of the motor itself may cause a malfunction. Therefore, anti-vibration rubber is used to reduce the vibration of the motor itself. The equipment configuration shown in the figure can be modeled with the spring mass system of the 1 degree of freedom model. The figure on the right is a 1 degree of freedom model. The motor is modeled with a mass, and the rubber is modeled with a spring. X is the displacement of the mass at this time. As an example, consider the case where the mass is 100 kg and the force F is acting. At this time, the frequency characteristic of the displacement of the mass changes depending on the spring value K. In every line, there is a frequency at which vibration is predominant, and this frequency is called the resonance frequency. Since it is a 1 degree of freedom model, each line has one resonant frequency. The resonance frequency can be obtained from the relationship between the mass and the spring. If you want to reduce the vibration of the motor, you need to select the spring so that the rotation speed of the motor does not match the resonance frequency of the 1 degree of freedom model. In this example, it is assumed that the mass cannot be changed. You can see that the graph changes greatly depending on the relationship between the mass and the spring. In particular, it can be seen that the amount of change due to static force affects the wide range of frequency. Normalize the difference in this static force displacement and compare only the effect of the spring constant. The static displacement xst can be expressed by static force F divided by K. Normalizing the displacement x with the static displacement xst results in a graph. Furthermore, we will consider how to reduce the vibration of the mass by normalizing it with the resonance frequency. This graph is normalized by the resonance frequency and graph shows all line become same values. When frequency ratio is lower than 0.5, the displacement ratio is about 1. Then, when the frequency ratio is 1, which means resonance frequency of motor and motor rotation frequency is matched, the vibration will be increased. On the other hand, frequency ratio is 2 or more, the vibration will be decreased. Thus, to reduce the vibration of mass, rotation frequency of force frequency is bigger than the resonance frequency. This is the example question. When a motor speed is from 0 to 1000 rpm, how should be a rubber's spring value of K to reduce vibration? 600 rpm means 600 rotation per minute, so frequency is 10 Hz. 1000 rpm is 16.7 Hz. If I have deal with the question, I try to do below. Try to use blue range frequency only. Try to use red range frequency, when motor speed is 600 rpm or more. If I want to use the blue range frequency ratio is under 0.5. Therefore, spring K is this value. On the other hand, if I want to use the red range frequency ratio is over 2.5. So, spring K is this value. When I use blue range frequency, the concept is not to reduce the vibration of motor. It aims to use motor speed under resonance frequency because vibration of motor is not so large. In contrast, when I use red range frequency, the concept is to reduce the vibration of motor. This slide shows 6.3 times 10 to the power of 4 or less, so from the word or less, some people think anti-vibration rubber should be extremely soft to make small spring K. However, it is bad solution, because it cause a failure by large deformation from static force and low frequency force. Finally, engineer should decide which range of frequency is the suitable for motor THA.